Being started.
And 16. So just keep in mind that the material covered tonight is not exhaustive. These are just some high points that students have struggled with past. So other questions, feel free to ask those, and we'll do our best to help you out with those too. So the first slide, it just is covering our topic, right, for the module. If you're in the 8-week course, if you're in the 16-week course right now, you're focusing on quiz 16. But we recognize that life is diverse, right? And we also observe that there are many interactions between the living systems, which we call biotic systems, and non-living or the abiotic systems. And Professor Plummer said, we're also going to talk about here how life is finite, and that the physical life that we know has an end to it. So let's start with Chapter 14, a few points on Chapter 14 that, life is diverse. As you've learned in your reading and study of Chapter 14, we need to examine the diversity of life. There are many challenges to that process of classification. So what we find in these challenges is that there is great diversity among various species. Take, for example, some pictures here just from behind my house. Some pond water pictures I took, or just, in a creek, or this click beetle. Life is very diverse. In regards to origins, to begin with, the attempts to organize that entire created order become very problematic. Right? There are differences of opinion regarding the origins of diversity. So we're familiar with these three challenges described in Chapter 14. The challenge of many different species, the complexity of life, also some ignorance packed in regarding the origins themselves. So there's concepts of taxonomy and systematics. And as I was reviewing quizzes that students have taken, there's problems with those. It seems like these two terms are often misunderstood. So within classification, we scientifically name each variety of life form and other species in what we call taxonomy. It's a very orderly system. We have this idea of kingdom, phylum, class, order, family, genus, species. Make sure you're familiar and know that order of classification. It's commonly confused with systematics, which also attempts groupings of life forms based upon assumed evolutionary relationships. So we examine the characteristics of life forms at levels and divide these into smaller number of large groups. Also, as part of the chapter, it talks about 7 characteristics that are used in classifying life forms. Note that many of those important biological characteristics for classification are actually cellular or molecular in nature, so very at the small level of complexity. An example of this classification process is found in Figure 1414, where we see the physical and shared characteristics within the taxa. For example, in the class of mammals, we have warm-blooded organisms with double circulation, placenta, and hair. Those were the big points from Chapter 14. Let's jump to Chapter 15 here. Review some major concepts in ecology. And it means the study of our home, or oikos in the Greek, more specifically, the interactions between biotic and abiotic. We see this a creation that is wrought by sin. This is a result. As a result, we observe species interactions that include things like predation or parasitism. We also carnivores and other factors such as disease. Chapter 15 begins with an exploration of a lake. Here's a picture of a lake just right by my home here. And you should be able to name the basic zones of a lake. And they do that. So Chapter 15, Section 1 there talks about the zones of the lake and how an ecologist would approach the study of the lake. Those zones we should come up with are the littoral, the netic, and the fundal zones, Figure 15.3. The important ecological features of a lake discussed as part of the text involve the movement of nutrients lakes in this part of the world undergo a spring and fall overturn event. The wind comes over, the seasonal changes, it churns up that water. It's up that stratification in the water. This type of event brings up nutrients, phosphates and nitrates discussed in the text there, that are released by decomposers into that profundal zone and into the limnetic zone, where we find many of the plankton. So you want to relate and connect these ideas of the zones to this relationship between the living and the non-living, the biotic and the abiotic. This is an example of how the plants are dependent, in this case, upon the abiotic features, such as light, nutrients, for survival. An important feature of aquatic life involves the unique properties of water. We studied properties at the beginning of this course as we explored the chemistry of life. Recall that water is less dense as a solid. And you should ask yourself, how would this be beneficial to aquatic organisms? If you're thinking about, a solid that's forming ice, you'd buy a tractor because, the ice floats. And when it floats, it provides a buffer for life during the winter months. So those were some big takeaways from that part of the book, some application of this interaction between living and non-living. And then we did this idea of a population and community and an ecosystem. So look about a community first here. So, what is a community? Here we have a concept of interacting species in a geographic area. So different species relating with one another. A habitat, an important term, habitat is specific to the place where one lives. The concept of a niche is specific to the functional role of a species within community structure. Take this trout, right? All of the like species of this trout living in this region of a stream would be a population, right? In other sense, the trout interacting with other species, such as bears and the birds, would draw us out to the concept of a community. Make sure you have a good handle between these ideas of population and community. Make sure you can distinguish between those two terms. The interacting with its physical environment would be habitat, right? That habitat is interacting with. And the niche would be this fish's functional role, such as the role of a predator, right? This fish is a predator. And this organism exploits and uses available resources for survival. With populations here, we just love to study various dynamics in populations. And we can recognize a population as being, quite simply, a group of the same species, same geographic location. Now, ecologists can examine and estimate the density of a population. Remember, density is number of organisms per unit area by various methods. One that's discussed, and you make sure you're familiar with, that mark recapture method, a way to estimate the overall size of a population, and that's described as taking a sample of the population and giving it some kind of a mark. Maybe you paint something on it. Maybe you make some kind of notch in a turtle shell. Some kind of mark on the organism. Release it, and then out again and do a second capture event. And how many within that second capture have been from the first. And you can use that information to estimate the size of a population. So that concept of mark recapture on page 540 in your text. And populations also tend to organize into three basic distribution patterns, right? You see here in front of us here, right? We got random patterns, we've got uniform patterns, and clumped. So these distributions tend to be related quite often to available resources, where random situation tends to be a situation where there's abundant resources. In the case of these here, different types of plants. I think this is a description of bushes in your text there. Uniform being territorial, as you can see this penguin breeding ground here. They're all somewhat spaced out in this nesting motion. And then you got clumped, where you have strong social interaction, like a school of fish. What to keep in mind is that, or quite ask yourself, does the scale matter, right? If I was to zoom the penguins here, it is uniform. But if I was to kind of back up and zoom out, get an aerial view of these penguins, it might look more like the fish there. It might be kind of clumped, right? So scale matters too when you look at these distribution patterns. Then we have demographers, right? People that study human population specifically. And there's text of these age structure diagrams on the right here. Diagrams can be useful in predicting future population growth or decline. We call growth decline, a lot of times that's related to births and deaths or the immigration, but you'll want to be able to interpret these, right? So if we're looking at this, for example, population, very few, let's say, pre-reproductive individuals. And if you look at on the right there, you got different groups of individuals. You got pre-reproductive, reproductive age, and then post-reproductive age. One female in a population. What do you expect for the population to be declining? You can see it on the right there, right? The one that has very few pre-reproductive age individuals. And stuff like that population disappeared altogether. Where on the far left, with lots of pre-reproductive individuals, is not just increasing, it's increasing rapidly.